Alrighty. So today is Thursday. So I'm going to go to my work menu for Thursday and I'm taking a look. What is the math book lesson for today? And the math book lesson for today happens to be chapter 8, lesson number 9. And as always, you can see down here at the bottom, this is a digital link to the pages that I am expecting you to complete for participation, okay? So let's go over what Chapter 8, Lesson 9 is exactly. So I'm going to come on over here to my document camera, and we're dealing with mixed numbers. When we are working with mixed numbers, there is a few bits of vocabulary that I'd like to go over and also just sort of a quick visual. And that will come in the form of a number line. Now, when you started school or when you started fourth grade, we spent the beginning of the year working with 0, 1, all the way to 999,999. Those numbers to the 100,000s place. Okay. And that gets us to 999,999. And then Mr. Tillish said, all right, now we are dealing with fractions. And when we dealt with fractions, we stepped away from the number line that goes from 0 all the way to 999,999, and we went all the way over here. And we are in the area of between 0 and 1. That's it. Every number that's tucked in here between 0 and 1. You can see I blew up the number line here between 0 and 1. That's where all of your fractions are, okay? From 0 to 1, you got 1/2 in the middle. All of your fractions equivalent to 1/2. 1/2, 4/8, 8/16, 3/6. All of those here. 2/3, and all of the fractions equivalent to 2/3. All of your fractions are between 0 and 1. And now today, because we're working with mixed numbers, we're looking kind of like at a number line that looks sort of like this. 0, then you got 1, you got 2, 3, 4, and let's just say 5, okay? And we're dealing with, yep, we're still in the fractions, but we're starting to build an understanding that there are fractions that exist between 1 and 2 and 2 and 3. Those of you that have younger siblings and someone asks you, oh, how old's your little sister? And you might say that she's 2.5, right? So that's 2.5. Or maybe you are really, really excited about Christmas and you're like, man, how far away is Christmas? And you really have been paying attention. You're like, man, it is 4.5 days away. So you got 4.5 here. And so we're going to be dealing with mixed numbers today, and mixed numbers are not just the fractions that are tucked in between 0 and 1, but it's the whole numbers, right? And the fractions that are in between them. So that might take the shape of looking at a mixed number that looks like 3.5, right? So we can look at 3.5, one on a number line. 3.5 is going to be, well, there's 0, 1, 1 to 2, 2 to 3, 3.5. That is, I'm sorry, I just wrote 3.33. That is 3.5 right there, right? So we're working between all these whole numbers and the fractions that exist between them, okay? So 3.5. A mixed number consists of a whole number, 3, and a fraction, in this case, 1/2. And visually, 3 is a whole number, so it's all these wholes, 3.5. We're dealing with halves, okay? In order to get halves, you've got to complete the halves. You've got to have them all, right? So 3 is 1/2 and 1/2, which makes 1 whole. Then you have another 1/2 and a 1/2, which makes another whole. Then you have a 1/2 and another 1/2, which makes another whole. There's our 3, 1, 2, 3, and then we have 1/2. And if you put those together, that creates the mixed number 3.5. So not only did you have 1 whole piece of whatever, or 2 whole pieces of whatever, or 3, you had 3.5. Okay, so there's your number line visual there. All right. Some key vocabulary that we're going to want to understand before getting into this is the idea of what a unit fraction is. Unit fraction is a fraction with 1 as a numerator. 1/3 is a unit fraction. Your number line, okay, or excuse me, your fraction strips are showing unit fractions. These are all unit fractions. 1/2, 1/2, 1/3, 1/3, 1/3, 1/4, 1/4, 1/4, 1/4. All of these are unit fractions, right? Okay, these are all unit fractions. They have 1 as a numerator all the way down here. Okay, unit fractions. The next vocabulary or direction that we're really going to want to pay attention to is sum of a whole number. 3 is the sum of whole numbers. 3 is the sum of 1 plus 1 plus 1. 4 is the sum. Sum means the answer to an addition problem. 4 is equal to 1 plus 1 plus 1 plus 1, right? So the idea of a mixed number, a unit fraction, and the direction that's going to be given to us, sum of a whole number. Okay, the sum of a whole number is or are going to help us to be successful with this lesson today. Okay, so let's take a look at the independent practice that we have going on, all while referring back to this bit of a guide here. Okay, you can see you have the sum of the whole number. Here are your wholes, right? 1 whole and 1 whole and 1 whole. If you add those up, that 1 plus 1 plus 1, that 1 plus 1 plus 1, you get your 3. And then you add your unit fraction, your 1/2, 3 and 1/2. Okay. So going back into unit fractions, I'll teach you a little bit, give you some guides on how to write out unit fractions for fractions that are not unit fractions or do not have 1 as a numerator. So let's take a look here at our independent practice. We are going to look at word problem number 12. We have a young man, his name is Alex. He has 1 whole orange and 1/4 of a second orange. Write a mixed number that represents the amount of oranges that he has. So he's got an orange, right? And then he's got another orange. Okay, it seems like, he was at home, he's in quarantine, he was eating a snack, and he had an orange that was broken into fourths here, and he ate it all, right? 3, 4, 4 slices. He ate 1 whole orange. Then he ate 1/4 of a second orange. If you add those up, 1 plus 1/4, he has eaten 1 1/4 of an orange. Okay. Write a mixed number that represents the amount of oranges he has. Okay. Another way to look at this is he ate 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. He ate 5/4 of an orange. This is the idea of the improper fraction, which means that the numerator is larger than the denominator. The way that we write that appropriately is it's mixed number. Okay, it's whole number and fraction. Okay. All right, let's take a look at number 13. Brooke gave her dog 2 whole dog biscuits and a half of a third. Write a mixed number that represents the amount of dog biscuits she gave her dog. Well, you got your biscuit, okay? You got another biscuit, right? And a third of another biscuit, okay? Make sure all these biscuits are the same size, close to anyways. And she ate 1 whole biscuit, another whole biscuit, okay? Making sure that these biscuits, they're all in thirds, okay? The fraction tells us third right there. We're dealing with thirds, okay? Now, and then 1/3 of another biscuit. So maybe the dog was catching and fetching the ball. Its owner broke each dog treat into thirds and then gave a third for bringing it back, another third for bringing it back, another third for bringing it back, another third, another third, another third. Okay, and that equaled 2 whole dog biscuits. And then a third of another biscuit. So we got 1 whole dog biscuit, we got another whole dog biscuit, plus another 1/3. 1 plus 1 is 2, plus your 1/3 is 2 1/3 dog biscuits. Biscuits. Yeah. Alrighty. Let's take a look at the front just so that when you go to solve the problems on the homework page, you have an idea. I won't just stick to the word problems. A mixed number for the shaded model. Well, you can see the holes, right? You can see that they're broken up into fifths. So you know you're working with fifths. And we have 1, 2, 3, 4, 5 fifths, which is 1 whole. And then we have 1, 2 fifths. 1 plus 2 fifths is 1 2 fifths. Then we have 1 2 wholes and another that's a fraction of. We have 1 2 3 4 5 6. So we're dealing with 6 sixths, okay? Or 1 whole plus 1 whole plus 1 2 3 4 5 sixths is 1 plus 1 is 2 and 5 sixths. Okay. Now, let's take a look at 3 1/4. Let's take a look at this directions of this second part. This is why I front-loaded you with the idea of what the sum of a whole number is. A sum of whole numbers. Okay, sum of whole numbers. 3 is the sum of 1 and 1 and 1, and 4 is the sum of 1 and 1 and 1 and 1. All right, so let's take a look at these directions. And we'll notice that we have 3 1/4. Okay, so we write an equation that represents each mixed number. Okay, we got to represent each mixed number as the sum of whole numbers and unit fractions. So here we're going to have a series of ones and a series of unit fractions. So 3, we've already determined, is the sum of 1 plus 1 plus 1. So we have 1 plus 1 plus 1 plus, well, good for us here, we've already got a unit fraction, 1/4. Here we have 5 1/2. We have 5. I'm gonna have you do this one, or work through it. Not fair, I didn't assign that page. Can't do that. So 5 is the sum of, well, if 3 is the sum of 1 plus 1 plus 1, and 4 is the sum of 1 plus 1 plus 1 plus 1, 5 is going to be the sum of 1 plus 1 plus 1 plus 1 plus 1 plus 1/2, because we already have the unit fraction. Here is where it gets a little bit different, okay? So 2/3 is going to be the sum of unit fractions, right? 2/3 is going to be the sum of unit fractions. Let me do an example here. If 3/5 is the sum of unit fractions, 3/5 is the same thing as 1/5 plus 1/5 plus 1/5. Okay? Unit fractions with a 1 as the numerator. So here we can look at 2/3 as the sum of unit fractions as well. But we'll start with our 2. 2 is the sum of 1 plus 1. 2/3 is the sum of 1/3 plus 1/3. Okay. 4 is the sum of 1 plus 1 plus 1 plus 1. 3/8 is the sum of 1/8 plus 1/8 plus 1/8. Okay, the denominator doesn't change, but it's how many units, how many ones do you have to add together to make 2/3? How many ones do you have to add together to make those 3/8? Just like so. All right, boys and girls, good luck with your math assignment, and please let me know if you have any questions. Take care.